Good afternoon, all of you. Is my voice is audible? Yes, this is audible. Yes, all of you scan this QR code for the attendance. All of you scan this QR code. Is my voice is audible?
Yes, sir.
Okay, so what we are discussing? So we are discussing the deadlock avoidance. On that, we have, I think, we have completed the banker's algorithm. Yes. Listen now. So we have discussed deadlock
Yes, sir.
avoidance method. So what is deadlock avoidance? Okay. Then we have discussed that what you mean by safe state and what you understand by unsafe state. Okay. So then if the system is in safe state, there will be a safe sequence. Fine. So these are the conclusion that is made based on the deadlock avoidance. Now if the system is safe, then no deadlock. And if the system is unsafe, then possibility of deadlock. Okay. There may be a deadlock or not be a deadlock. Then what avoidance say? So deadlock avoidance ensures that the system will never enter to the unsafe state. Okay, so whenever the system is entering to the unsafe state, we will not grant that request. We will not allow that request to happen. Fine, so these are the conclusions. Okay, these three conclusions are basically we can draw. Okay, these three conclusions are drawn from the deadlock avoidance algorithm. Fine.
Yes.
We have discussed the banker's algorithm. Okay, so these are the data structure that we need. Then this is your actual algorithms. Okay, how it is implemented. Now, first step you have to remember in this case, whatever you requesting should be less than need. Okay, the first step you have to check. What you have to check? The request should be less than equal to need. If it is true, okay, if the request is less than need, then we go to the step number 2. If the request is greater than need, okay, whenever the request is greater than need, so it will show an error message. So it will be not granted. It is not possible. Fine. Now, if the request is less than need, so we will go to the next check. Now we will check if the request is less than available. Okay. Now, if the request is less than available, so we will further proceed. So what we have to do now, we will calculate the available matrix. Okay, now available will be new available will be available plus request over enter. It will be plus. Now new available will be available plus request. What is requested? Now allocation will be uh, allocation plus request. Then need is what? Actual need minus request. Then we will run the we will update this data structure. Then we will run the bankers algorithm to check whether the system is safe state or unsafe state. If the system is safe, the resources are allocated to PI, and if the resource is unsafe, okay, or the system is unsafe, then PI must wait, and the old resources allocation are restored. Fine. So this is the algorithm that we have implemented. Okay. So we have solved some problems. So we solved this problem. We have also solved this problem. Okay. Now today we will going to discuss a new topic, or you can say second method of detecting a deadlock, which is called we already discussed this one, resource allocation graph. So in this graph, basically uh, the resource and process are uh, designed in the form of directed graph. Okay. So today we will see how we can derive a weight for graph. Okay, how we can derive a weight graph for from this resource allocation graph. ठीक है, तो resource allocation graph से आप weight for graph कैसे बनाएंगे? So basically weight for graph are used for detecting the deadlock. Fine. So let's understand first of all what you mean by resource allocation graph. First of all, you have to this resource allocation graph algorithm are basically used for deadlock detection. Okay, deadlock detection purpose. Fine. So this is the third method. Okay. So as we have different methods of deadlock पढ़े थे, तो first method क्या था? Deadlock prevention. Second method क्या था आपका? Deadlock avoidance. Now third method is deadlock detection. Okay. So in case of deadlock detection, we will use. So what basically we are doing in deadlock detection, we will allow the system to enter the deadlock. Okay. Then once the system is in deadlock, we will detect the deadlock, whether the system, whether there is deadlock in the system or not. Fine. For that, we will use this resource allocation graph algorithm. So what this graph says, now there is a claiming edge. क्या होता है? Claiming edge, which is represented by PI requesting. Now what we are writing, there is one claiming edge, which is PI से आपका RJ, or we can say request edge भी बोलते हैं कभी-कभी. ठीक है? These are my claiming edge or request edge. This basically indicate that process PI, okay, PI may request a resource RJ. Fine, and it is represented by a dash line. Okay, so in a graph, suppose this is my process P1, and this is my resource R1. So what the claiming is say? Claiming is क्या बोलता है? Now claiming is nothing but it will be represented by a dash line like this. Okay, dotted line. And what is say? Now process P1 is requesting, the process P1 is requesting uh, the resource R1. Fine. Okay. Is I'm audible? So what is this? Is this edge can be this or this edge can be set as a claiming edge or requesting edge. Okay. Next thing you have to remember, the claiming edge convert to the request edge. Okay. When I convert this claiming edge to request edge, So when the claiming edge will convert to request edge when the process request a resources. So I can say now first of all I'm claiming. Now this claiming edge will convert to the request edge whenever the process will request a resource. So when the resource is released by the process, the assignment edge reconvert to the claiming edge. That means once the process P1, okay, once the process P1 complete its task, okay, once the process P1 complete its task, fine. Suppose the process P1 complete its task, so what happened? Now it will release its resource. Now again this request S will be converted to the claiming S. That means it will be again converted to dash line. And resource must be claimed a prior in a system. That means all the process have to uh, define number of resources which is required before starting the system, before implementing. Okay, it is called prior of the system. Fine. So what is prior system? Nothing but all the process that are requesting for resources have to request before the execution. Fine. So this is something about what you mean by claiming edge and how claiming edge will be converted to the request edge. Fine. And then when the process complete its task, then again how it is converted, how your resource or the request edge will be again converted to the claiming edge. Fine, now we will use this claiming edge. Okay, now you can see in this slide. Okay, so in this slide, so what are my claiming edges? Can anyone identify what are my request edge and what are my claiming edge? So what claiming edge say? In the future, to complete this task, the process may request this resource. Fine. So what are my claiming edge here? Now you can see this edge from P1 to R2. P1 to R2. Now this is my claiming edge as it is represented by dot line. Similarly, P2 to R2 is also your claiming edge. Right. And what is now once it made a request, okay. Once it made a request, so this dotted line will be converted to your request edge. Okay. So you can see in the next slide. Yeah. In this slide, you can see now what happened. So once P2 is making a request, once P2 is making a request, so what happened now? The dotted line is converted to the request edge. Fine. So you can see in this graph, okay, in the previous graph, what is that? It is a dotted line. Okay. So it is requesting for this. So it is claiming for R2. So once R2 is assigned, okay, now you can see once the R2 is assigned, so it is converted to the request line. Okay, or we can say request edge. Now R2 is assigned to P2. Now once it will complete its task, now once P2 complete its task, now it will be release R2 and again this edge will be converted to the dotted line. Fine. This is how we can differentiate between a claiming edge and between a request edge. It is clear to all of you? Is it clear?
Yeah.
Okay. So if we go back. Yeah. So the main objective of resource allocation algorithm is find the deadlock. Okay. Now suppose this is my resource allocation graph. Okay. So I already discussed the resource allocation graph. The graph consists of set of process, set of nodes, which is nothing but process and resources, and set of edges. Okay. Now suppose this is the graph given. Okay. So what we have to do now, I have to convert. I will convert this resource allocation graph to wait for graph. Okay, what we have to do now, because as there are two types of nodes, so sometimes it is difficult to find the cycle. Okay, so simple concept, again same concept will be there in the case of wait for graph also. So what is the concept? if there is a cycle in a wait for graph, okay, if there is a cycle in a wait for graph, then there will be a deadlock. Fine. And if there is a no cycle in my graph, if there is a no cycle in my graph, then there is a no deadlock. Okay. Now, how you can draw the wait for graph? So, wait for graph is consist of only process. Okay, it will not consist of resources. So, I will write the process. So, the process available now. The process available P4. Okay, careful listen. P1. Then there is a P2. Then P3, and we are having P5. Okay. Now, how we can draw the wait for graph? So, wait for graph basically, uh, it's basically show the dependency between the processes. Now, suppose now if you want to find the edges, dependency edges of P1, now you can see here R1 is already now. Oh, sorry, R4 is already allocated to P1. Now it is requesting for R1. Okay, it is requesting for R1. But you can see here the R2 is occupied or allocated to P2. That means how to complete the P1, okay, to complete the P1, before that P2 must be completed, because if P2 will be complete, then only, okay, once P2 will be complete, if P2 will be complete, then only it will release these resources. If it releases resources, then only I can allocate this one. That means now the completion of P1 is depend upon completion of P2. So what I say now, P1 is depending on, sorry, P2. It is P2, no? So I have to write. So what happened here? Now completion of P1, completion of P1. Now it is depend upon what? It is depend upon completion of P2. So I will draw an edge from P1 to P2. ठीक है? Clear? Now और किसी पे डिपेंड है P1, देखो यहाँ पर और किसी पे भी डिपेंडेंट नहीं है. फाइन, दो ही रिसोर्स चाहिए था, इसको R1 चाहिए था एंड R4 चाहिए था. R4 ऑलरेडी है. नेक्स्ट R1 चाहिए. R1 किसके पास है? P2. दैट मींस P2 कंप्लीट होने के बाद ही वो रिसीव करेगा. तो इसके डिपेंडेंसी क्या? P1 से R1. Now coming back to P4. If you see the P4, what resources is required? It required only R2. It required only R2. Fine. Now R2 is already available. R2 is already available to it. That means there is a no dependency. Now P4 is not depend upon any of what? This process. So there will be no edge for P4. Now coming back to P2. Fine. अगर हम P2 को देखेंगे, what it is required? What it is required? The P2 is required. P2 is required R1, R2, R3, and R5. What is available? R1 is available. What further is required? It required R2. If it is required R2, so it depends upon completion of P4. Now it depends upon completion of P4. So I will draw an edge from this to this. Now if you want R3, so it depends upon completion of what? P3. Yes or no? If you want to complete this process, okay, if you want to allocate R3 to P2, now first of all, P3 should be completed, then only to release, then you will allocate it. And this, there is a dependency from P2 to P3. Similarly, there is a dependency from R5, which is allocated to P5. So there is a dependency to P5 also. So there will be edge from P5. Fine? It's clear? Yes? It's clear how I'm drawing the edges? Now P3. P3 का क्या होगा बताओ? What edges should be drawn to P3? Now what resources is required? It's required R3 and R5. So edge कहाँ से होगा P3 का? Now if you got R5, so R5 is already allocated to P5. That means it will wait for completion of P5. So there will be edge from P3 to P5. Fine. Now coming back to P5, if you see the P5, so what you require? You require R5, you require R4. So R5 is already there, but R4 के लिए किसके लिए wait करेगा वो? P1 के लिए wait करेगा. Now you can see there is edge P1 से क्या है? P5. Fine. So this is my complete wait for graph. WFG. Yeah. wait for graph. Now this is the equivalent wait for graph for this resource allocation graph. Now if you see here, so अब cycle find करते हैं. I will start from P1. So if there is a cycle, you can see we have P1, P2, P3, P5, and again P1. So there is a cycle form. What are the nodes involved? P1, P2, P3, and P5. Now this P5 again kahan hai? P1. Now there is a cycle between this one. Now you can see there is one more cycle. If you see here, yeah, this is the biggest cycle. You can now there's cycle P2, P3, and P5, which is already there. Okay, so obviously again repeat the cycle. Okay, here now as there is a cycle in my graph, okay, in my wait for graph, so I can say if there is a cycle, then there will be definitely deadlock. Fine. It may be single instance or multiple instance. Okay. Whether there is a single instance or multiple instance, if there is a cycle in my wait for graph, okay, if there is a cycle in my wait for graph, then I can say the system or system is in deadlock. It is clear to all of you? Is it clear how we are finding wait for graph? Okay. So it is clear. Try this question. Yes. Draw the wait for graph for this one. Draw the wait for graph for this one. And check whether there is deadlock or not. Draw the wait for graph, equivalent wait for graph for this resource allocation graph. Now this is my resource allocation graph. Okay. Now what you have to do, now you have to find equivalent wait for graph. Sorry, the blue F. And check whether there is deadlock or not.
There is no deadlock for wait for graph. Sir, there is no cycle formation.
There is no cycle formation. So what we can conclude, if there is no cycle, if there is no cycle, so I can say there is no
So sir, this graph does not hold any deadlock
any
condition.
deadlock. Okay, this graph or system we can do, not just graph, we can say system. The system does not have any deadlock. Yes, और किसका आ रहा है? Yes, और किसका आया? There is no deadlock. Now what is the process involved? Now if you write P0, okay, P1, now there is P2, and there is P3. Fine, there is P3. Okay, these are the four process. Now you can see, so what are requests required for P0? P0 requires A, and It is required B. It is requesting for B, and it is requesting for what? E. Fine. So A is already available, B is already available. Now, for if you're requesting for P1, now how many instances are there? Two instances are there. One instance is available, so I can allocate. So no dependency. Now E. Now if it's requesting for E, there is only one instance. So only one instance, and who is allocating this one? P3 is allocating. So there is a cycle from P0 to P3. सिमिलरली फॉर P2 देखेंगे तो A चाहिए, ठीक है, B चाहिए. नाउ B इज ऑलरेडी है, A इज ऑलरेडी देयर, रिक्वेस्टिंग फॉर C. C का एक इंस्टेंस है, तो आई कैन allocate this one. Now it's requesting for E. Now E is only one instant and that is occupied by P3. So P1 से भी P3. Now P2 को देखेंगे तो क्या चाहिए उसको? B ऑलरेडी है. Now it is requesting for E. E is already occupied. Now P2 से भी P3. Fine. Now coming back to P3. Now what it is requesting P3? P3 is requesting for resource E. Okay, P3 is requesting for resource E. Fine. Now it is requesting for resource C. So can I allocate now one resource is already available, so I can allocate. But can I allocate this one? Yes, I can allocate because this resource is not occupied by any of you. So there is no edge. Fine. अगर ये resource किसी को allocated होता, wait. So there is right. So it is not allocated, no? So it will be no cycle. Okay. So the wait for graph will be P0, P1, P2 and P3. Okay. और हम उसका वेट पर ग्राफ बनाएंगे. ठीक है. अभी क्या चाहिए था इसको? नाउ P1 P0 को क्या चाहिए? A B ऑलरेडी है, B चाहिए, B का एक इंस्टेंस खाली है, so I can allocate. No problem, no dependency. Okay. Now if want E, now E is not occupied to any of this. Okay, so I thought this is allocated to this one. So this is not allocated to this one. So there will be no dependency. That means there will be no edge from P0 to any of this. Similarly for P1, P1 के लिए भी कोई भी edge नहीं होगा. So only P2 will there will be no edge, no dependency. Similarly P3 will be no dependency. Now this will be your only graph. Good. The graph will have no edges. Fine. Why there is no edges? Because there is no dependency. The process are not dependent on each other. The process are not dependent on each other. So there will be no edges. Okay. So those can come. So we can. This is a graph. Okay. We can say this is a graph which is having no edges. Fine. Is it clear? So if there is no edges, so there cannot be chances of forming a cycle. If there is a no cycle, so I can say there is a no deadlock. Okay. Okay, fine. So we have discussed lots. So this is something about deadlock detection. Okay. So what is deadlock detection? Basically, say deadlock detection. Say we will allow the system to enter to deadlock state, then we will recover. Okay, then we will recover. So how we will detect? Now once the system will be allowed. So first of all, we will find a resource allocation graph. Okay. So first we will find a resource allocation graph. Then I will convert this resource allocation graph to wait for graph. Okay. So once I convert this resource allocation graph to wait for graph, if the graph consists of cycle, okay, the graph consists of cycle, then I can say there is a deadlock. Fine. Now, if the graph consists of no cycle, the wait for graph consists of no cycle, then I can say there is no deadlock. Fine. This is our conclusion. This is our conclusion. Okay. The last technique, which is called deadlock recovery. So what it basically says, so whenever the system, okay, whenever if the system enters to a deadlock, okay, अगर system आपका deadlock हो गया, then we have to recover from it. So how there is a two possibility of recover. One is called your rollback. Okay, continuous rollback बोलते हैं. What we say, rollback method. So what rollback method is say? Rollback means we will, if some request is causing a deadlock. Okay, suppose I granted some request. Okay, suppose I granted some request for P1. Now suppose this request is causing a deadlock. Now what I have to do? Now I have to roll back to the previous request. Okay, on previous state where the deadlock is not happened. Suppose the previous state is something called P2. Now suppose P2 is also causing a deadlock, then again I will go roll back to the its previous state. That means P3. Now this process will continue. That means the rollback process will be continue until we will find a particular safe state. Here, this is the first strategy of recovery, how we can recover. So what we are saying, so whenever there is a deadlock, okay, so we will start rollbacking, okay, we will start roll back to the previous state, okay. Now if the previous state is safe, then it is okay. If it is unsafe, then again we have to roll back. Now this process of rollbacking, means continuous rollback process should be continued until you find a safe state, until you find a safe state. Fine, this is continuous rollback. But one problem is that one of the problem may occur. Okay, it may be case the process P1 will never will execute. If you continue making rollback, okay, continuous making rollback, ऐसा chance आ सकता है. Okay, the process P1 sometime may never get a chance. So that may be cause of starvation. Okay, there may be continuous rollback करने से क्या problem होता है? There may be problem of starvation. Fine, this is one of the problems that is facing in deadlock recovery. There may be faced the problem of starvation. Okay. Second solution is how we can recover all most of the system, whether it is a Windows system or Unix system. So what they're using the process, so they simply ignore the problem. Okay. So simply, if suppose the deadlock is happened, so what the system will say, simply it will ignore the problem and it will behave like the deadlock have never occurred in the system. ठीक है, क्या कर रहे हैं, क्या बोल रहे हैं, क्या solution है? Now most of the operating system will use this process. Okay, so what they will basically ignore the deadlock and pretend like that. Okay, and they behave like that. The deadlock is never happened. Just will be ignored. If the deadlock is happened, it will be ignored. So this is the method, or this is a technique which is used by most of your operating systems. Fine, clear? So with this topic, we have ended this chapter. Okay, chapters deadlock. Okay, or in the module 3. I think this is module 3. We will end this module. Okay. So what we have discussed. So first of all, in this module, we discussed what you understand by deadlock. Then we discussed what are the conditions for deadlock. Okay, what are the 4 conditions for deadlock? Then we have discussed how we can handle if the deadlock is occurring, then how we can handle. So we have discussed the 4 different methods for handling. Okay, on that, deadlock avoidance is important, where we have discussed 2 special type of algorithms. One is your bankers algorithm, second is your resource allocation algorithm. Okay, okay. Then lastly we discussed about deadlock recovery technique, and that is a problem regarding a deadlock recovery. There may be some chances when we are continuously rollbacking, then there may be cases where the system will have starvation. Okay, the system might go into starvation. That is, the low priority process may not get executed or may not get chance to the execution. But how we can pretend that most of the operating system behave like the deadlock is never happened. Just it will ignore the situation. Okay, so take your question. We are having 5 minutes. So if you are having any question regarding this module, you can ask me. Any question regarding this module? Because tomorrow onwards we will start with a new module or new concept, okay, new chapter. That's the reason I'm asking. If you're having any doubt in this module, you can ask me. Yes, any doubt?
Sir,
Yeah.
sir, can you tell how the problem is ignored in the deadlock recovery and the deadlock is recovered?
Simply suppose there is a deadlock happened. Okay, if I'm saying the deadlock is happened. Okay, so what it will do? It will suppose for example, suppose some process is not executing. Fine. Suppose you open a program, okay, a program of open pure. Now, sometimes it can see that it's not executing. It will take longer amount of time. So what we will do, that operating system will simply ignore that process. तो हम लोग कभी कभी क्या करते हैं, टास्क बार में जाके उसको फोर्सफुली बंद कर देते हैं, या फिर कभी कभी देखते हैं कि कुछ टाइम के बाद ऑटोमेटिकली वो काम करने लगता है. होता है कि नहीं? कभी कभी अगर कुछ खोले हैंग हो जाता है, बेसिकली वी यूज द वर्ड हैंग. सिस्टम इज हैंग, प्रोग्राम इज हैंग. So what we do, either we will, the operating system simply ignore it. Now the operating system not find the solution. कभी भी वो रोल बैक नहीं करता प्रीवियस स्टेट में. करता है क्या? कभी कभी अगर 4-5 ब्राउजर खोल दे तो हैंग हो जाता है ना. तो ऑपरेटिंग सिस्टम वो ऑटोमेटिकली ब्राउजर को रोल बैक नहीं करता है. फाइन. तो ऑपरेटिंग सिस्टम क्या करता है? जस्ट इग्नोर कर देता है. तो यूजर व्हाट विल डू नाउ, यूजर फोर्सफुली आइदर क्लोज दैट वन, okay, either you will close that program or wait for some time to automatically recover. Is it clear? The operating system is completely ignored. Okay, the operating system will not perform any task if the deadlock is happening. Is it clear? You got your answer?
Yes, sir.
Fine. Yeah. Any other doubt? Anyone? Or which the doubt here? So tomorrow we will start process synchronization. Okay, that is very important concept. Not related to operating system. Okay, but any whenever you face a synchronization problems, okay, कहीं भी जब आप synchronization problem को identify करोगे, on that case we require this concept, process synchronization concept. You can see. Okay, so we will start with the first of all uh, how to create a process. Okay, some basic definition of how to create process, and when we are creating a process, then how this process are interdependent. Fine. If there is a dependency in the process, then that should be a process synchronization. So we have to synchronize the process so that the consistency should be maintained. Okay. So we will stop today's class here. Okay. If you are not having any further doubt, I will stop here. So I have saved the attendance for yesterday's lab because as the LMS is not working, so today is working. So I have saved the attendance for lab. So those who are present in the lab, so they can give the attendance. And the assignment 7 is uploaded. Okay, assignment 7 is uploaded in LMS. So you can now upload your assignment, yesterday's assignment. तो lab assignment देते आप इसमें upload कर सकते हो. Fine, is it clear? Is it clear to all of you?
Yes, sir.
Yeah, we can upload the assignment in assignment number 7. Okay, thank you then. Thank you for participating.
Thank you, sir.